So hello back, everybody. Hope we didn't lose too much people on the way. Okay, so in this part of the tutorial, sorry, I'm gonna come back to the. So I'm gonna come back to the schedule, so everybody knows where we are right now. Yeah, here in this website. So in this part of the tutorial, I'm gonna start talking a little bit about workflows in NOMAD, what they are, how we understand them, and how you can actually define your own workflows. No, so for those that were in the first block, you might remember that I showed you this DFT plus GW calculation, and then you saw like how you had this so-called single point DFT, single point GW, and then there was this extra entry generated. So we are going to go in details about that. I then told you, like, if you want to try it yourself at home, you can download this examples file, zip, and just make an upload, and then we are going to see how to define these workflows. No, again, you have the documentation here, and in this case, I'm going to use it kind of a lot, let's say. But okay, let's see how we do it. So let's go back to the beta version, okay, the entries page of the beta version, and then we are going to go back to this very scary NOMAD meta info page, okay. So before I told you, like, actually there are like four main sections in NOMAD: metadata, run, results, and then workflow 2. And then I left intentionally this behind, because now I'm going to come to explain in details here. This is not, strictly speaking, this is so these are not computational. So both results and workflow 2 and metadata are shared with experimental people. And the idea is that in NOMAD, we are actually developing now this idea of how you can define your own workflows to try to organize the data. No? So a workflow is a mean for organizing data and linking between different steps that you have in a calculation or an experiment, right? So I'm gonna show you in this case how you can define your own thing, and then how you can include it in your data and then make an upload. So in this case, just because we have to advance somehow, I'm going to create a new upload with the example files that I have before. So this zip file, just dragging and dropping, and in this case, it's a bit more of an involved example, okay? And I'm going to explain you how it is actually. So in this case, I want to somehow define some workflows. So well, before starting that, let me just explain what workflows is. So essentially in NOMAD, we have the concept of workflows as a mean of organizing data, and we have several concepts that are important. First, meaning that we have this keyword, not W, so the inputs of a workflow or a task, so the outputs and the steps that you do in the workflow, and then the links to these steps. No, so we also call steps task, and these kind of concepts are going to be floating around and are important for what we are doing. So it's better to see it like an example, and here I give you one with kind of a typical calculation that you can do. This is based on having some input that then is passed to some. So this is a fictitious calculation on some parameter. In this case, I just name it like pressure. So you are doing a calculation on 2 different pressures. Can be also like 2 different materials or whatever parameter you want to vary it inside the same material. And then we are performing a DFT calculation at these 2 pressures. And then on top of that, we are doing this kind of beyond DFT. So these extra steps that we want to know. It can be like a GW, can be a Bethe-Salpet equation. But in this case, I just took an example of having like a tie-banding model projection. And then on top of that, we do some dynamical mean field theory calculation at 2 different temperatures. Okay. So all of these in the form, all these square are what we call tasks. And then these tasks are linked in between them, and the final of the task in a workflow will produce some output of the whole workflow. No? So in this case, this will give you some output property at a pressure 1 and a temperature 1, and so on. No? So our task is going to be here. So if you see each of these individual tasks, it's what I was telling you before, like we call a single point calculation. And so if you did the upload, with this zip file that I give you, and then you go to the number of entries, you will see that actually you should get like 8 entries, no? And these 8 entries are related with single point for each of these tasks, let's say, no? So you will see a lot of DFT single point, projection, in this case, it's called projection single point, and DMFT single point. No? So if it finished, we should get 8 entries, and these are related with different pressures and temperatures. Okay. Then now I'm going to use even if it is the most dummy example, I'm going to try to code like a single point workflow. So the thing is that the story goes like this. So in NOMAD, we can actually recognize center workflows in an automatic way. And this makes your life easier, but there are some other situations in which this is not possible. So then, thanks pretty much to the development by other parts of FAIRmat, we give you like the possibility to define your own custom workflows schemas. Okay, this is the key, no? The difference between something automatic that NOMAD can recognize or something custom. I'm going to come at the very end about talking a little bit about automatic, because even though we give you this possibility, it's possible that we can define certain workflows in an automatic way, so you don't have to define them every time you upload your data into NOMAD, let's say, no? So then now this is the thing. So in this case, single point, so a single point calculation, like it can be like some singular DFT calculation or DMFT or whatever is already recognized by NOMAD. But in any case, I'm going to use it as an example to later like give you like tools to get more complex stuff, no? So in this document, and then we're going to do the single point, but in this document, there is like a set of tasks, exercises. So the single point, we are going to do it here. You can try this at home, like the other 2 cases, no? So we are going to try to define the pressure workflow. So for each of the pressures, we are going to try to define, the workflow, and then we are going to try to define the last task is try to define the top level workflow, no? Putting all the pressures together. So this will allow you to group the data in a kind of much more consistent and interesting way. So let's go with the example, and for that, the key is that NOMAD works like with custom schemas that has a YAML. So it works with YAML files. So you essentially have to create a new schema. Sorry, I'm going to move things around because I need the cheat sheet just in case I did something wrong. I promise you I will try to do it without looking at the cheat sheet. Okay. In any case, NOMAD actually works with these custom schemas are based on YAML file. And that's what we are going to try to create. We're going to try to create an extra file that we are going to include in our upload that is going to try to link between all these specific single point tasks. No, in the first case is going to be the example of the most single point. So the algorithm stuff. Let's see. So in this case, it has to have a very specific termination. So the file has to be terminated by this extension .archive.yaml. I'm using VS Code here just to edit the stuff. So let me call it, kind of call it like example, or in the case of, if you want to see the workflow YAML files that I included in the website, in the FAIRmat tutorial website, I think it's called single point. In this case, you can give it whatever name you want. And then now we are going to try to actually give the key ingredients to the final workflow. No? So the first one is that we are trying to populate the section workflow 2. And like I said, this is containing, if you remember the graph before, so sorry, because I'm going to be, sorry now, because I'm going to be switching kind of randomly between one or another. But if you remember the graph before, we have like some group of inputs, we have also like a group of outputs, and then we have like a set of tasks. No? So this is the 3 main ingredients that we have to define in a workflow. So inputs, outputs, and tasks. Okay. Tasks. Additionally, you can also actually give a name to your workflow, and to anything that can be also inputs and outputs. You can give a name, and in this case, I'm going to give you like a very random name. So once you are like treating this calculation, you want to organize the data like you prefer. And I'm going to be using for the single point, I'm going to be using the pressure 1 and DFT calculation. Okay. Now, in YAML, in order to define, so inputs, outputs, and tasks can be like a list of elements. And in YAML, in order to define that, each element of a list, it has to be starting with a hyphen, okay? It's going to be very simple. We are just going to define one input, one output, and one task, which is going to be the calculation itself, no? So for the inputs, again, you can define a name. I leave this to you. Well, I think I have to define something input and input. But then the key is that you have to define the path for a section. So the key is that we are going to define like, and then this is typical in these kind of calculations, we are going to define inputs and outputs pointing to a specific sections or files. This that I said sounds like a little bit complicated, but just let me write it and then maybe we can actually understand. So first you have to, there are different syntheses that you can use here. In this case, we are going to target the specific file of the DFT calculation, which in this case, we have to give the path to that file. And then it has to include this kind of string here, like uploads, archive, main file. And then in this case, it's going to be, you can actually, I'm going to try to open the upload that we did so you actually see it. So the path to this file is going to be this DFT pressure one XML. You can actually go to the entry of this file, and under here, there is actually the path to the main file. You can copy that to the clipboard. It sounds a little bit complicated now, but once you start doing it, it's kind of automatic now. So you can see that I'm actually not looking at the cheat sheet. So I'm going to check that actually it's upload and not uploads in plural. Okay, and then you have to include this hashtag thing, and then that will be already like pointing to the specific file that we want to target, so reference. And then we have to specify which section that entry we want to reference. Now, in this case, like the input that we are going to target is going to be the input system. So what material we are doing the calculation of. And if you remember a little bit the NOMAD meta info I was talking you about we were talking about the section in the block before. This is under run. Run is also a list. So in this case, it's always like zero. So in this excited state and correlated workflows is always the section, the element 0 of that list. And then it's going to be system, okay? And inside system, we also have to further specify which kind of system we want. So in this case, if a list, then it's the last system of all of it. So that's it. That's the section we are referencing from that specific main file that is in that relative, so in that path, sorry. Same can be done for the output. And in this case, it's going to be like the output calculation of the DFT, no? So you can imagine that the section path is going to be very similar, at least until the main file. And then we are going to target what is the output. So if you remember again from the last block, there are system and method as inputs, and then inside run, and then there is calculation, which is the output of any computational calculation. Okay. And with this, we already have like the inputs and the outputs, and then we have to define the task. And this is when this example gets a little bit dumb, let's say, because in this case, a single point is already, so it's already covered by NOMAD, but I'm just going to copy kind of like the syntax that you should be using if you want to define your workflows. The first thing that you have to do is like this task can be actually derived, so can be inheriting from an already defined class in NOMAD, and this is pretty much something that in like 99% of the cases you have to copy paste. It is exactly this example is the 1% of the cases where you should be copy pasting this mdef. In any case, we are going to do it here because later you have to copy paste. And then the task now again is the same kind of pointing to the same kind of path. Now the question is which kind of section we want to use here. So now we are trying to make this something from this main file. We are trying to make it like the task of this bigger workflow, no? This example single point DFT workflow. And in that case, it's always going to be contained in workflow 2. So this is again like these 2 lines are kind of copy paste that you have to always like maintain over the time. And then again, you can give it a name if you want. You can say like a DFT task reference, for example, reference. Okay, and that will be pointing. And because the task itself is a workflow, then you also have to define like inputs and outputs. And here there's a bit a specific thing. So if you want that all the tasks and all the inputs and outputs in your workflows are linked correctly, if they are like connected properly, then so let's say that you have a list of tasks, so now you want to define another task. No, so the key is that the inputs of the full workflow have to connect with the first task that you have, and then the outputs of the full workflow has to connect with the output of the last task that you have. And then in between, you can have all these links if you properly define the outputs from one and connect it with the inputs of the next one. Okay, this is much more visible, so you're going to understand this in the case when we are defining the pressure work. Okay, in this case, like this is more simple situation, then the inputs of the whole workflow has to coincide with the inputs of this specific task. Okay, and the same for the same for the outputs. And this is it. If we did everything correctly, we are going to see something very cool happening. So the thing is that now you can drag this into your upload folder. Let me just go to the upload. Okay. Now we have, again, we have like two different pressures with some files on it. So I'm just going to drag down this example.archive.yaml file that I created. Hopefully I didn't fail miserably. Also, then some process. Now I'm happy because I see that there is something like NOMAD. So now it's on the top level. Now this again, you can put them in soft folders if you feel that it's more organized. Just be careful when then doing these paths when trying to resolve like certain paths to files. Okay. And now if you see, now we have 9 entries instead of 8. And the extra that generated was this workflow YAML file that we created. And if everything went well, now you will see like this workflow graph, which, by the way, it is also present in any entry that is in NOMAD right now. If workflow 2 is present, so if you will go to any kind of, like, let's take this DFT calculation. Now this is already a workflow. Again, this is an employee workflow. So if you are at the very bottom, you should, apart from electronic properties, you should see the kind of similar workflow, no? Some input and output, and then some task in the middle. So we are trying to reproduce this using our own custom YAML scheme. In any case, if you go there, that's actually what it was looking like already. So even with the names that we decide to give, no, input system, example. So this is very reactive. You can play with it. You can zoom in. So again, this is a very dummy example. So if you zoom in, then you will get exactly the same kind of workflow. But we did it correctly. We link everything properly. And what is also very interesting is that whenever you click in these nodes, then you can actually go to the specific section in NOMAD. Well, in this case, there is some problem with the syntax -1, what we are trying to solve, but actually we are already targeting run system and then the last system of all of it. Okay. I think if I go back, I will go to the DFT entry here. So I should go clicking back. And the thing is that if there are tasks that are pointing to other entries in NOMAD, then you can click on that in the name, and then you will go essentially to that specific entry. And that means that you can essentially link. So let's say that you took like some DFT data from NOMAD, and then you did something on top of it, and then now you are uploading that top of thing thingy. You shouldn't be repeating that DFT data that you extracted with. You actually can link between that new data that you're included and then the DFT that is present in NOMAD by just including this kind of YAML files, or doing this automatic business that we can talk about later on. Okay, I hope this was not too much. What I'm showing, why am I showing like this writing a YAML file in real time is because writing a YAML is, you can actually automatize this very easily. You could have like a script that reads your directory tree, so the same as we have the upload, and then that you just have to specify which keys you want to define. So once you have this script, it's very easy to use it forward. In this case now, we are writing it by hand, but again, now what I want to do is once we define like the more complicated, the more simple workflow case. Now we're going to try to define a more complicated one, meaning we are going to try to define this pressure one workflow. So now you see, now we still have one input, but in this case we're going to have 2 outputs, and these 2 outputs have to properly be linked with the two last tasks inside the workflow now, and then we are gonna have essentially 4 tasks. The key here is that the output of the DFT task has to be connected with the input of the TV task, and then the output of the TV has to be connected with the input of the other 2 tasks. Okay. Because of time constraints, I have only 10 minutes left. I will just simply show you how the workflow YAML file looks like. Again, if you really want to learn how to manage workflows in NOMAD, I think you should actually try this tutorial yourself at home, but okay, I just leave it here. So again, this is the full pressure one YAML file. It contains one input, which is pointing to a system that is passed from the input structure of the DFT side, and then it has 2 outputs. Now the DMFT1, a pressure and temperature one, and the DMST, a pressure one and temperature two. And in this case, the path has changed because now we are targeting the specific section of that file, right? Which is calculation again, but then now the path has changed. Another task, I am just gonna collapse everything so it doesn't get you to scale. So now there are like 4 tasks, okay? And then this is when this definition, so this inheritance from task reference makes sense, because now we are pointing to single point calculations and try to put them in like a more complex workflow. No? So the first task is actually the DFT at pressure one. So again, it's pointing to the DFT1 path, and then we are trying to resolve first the workflow 2, then the input of that system, which essentially coincides with the input of the full workflow. And then the output is just the output of the DFT calculation. It happens so that if you go to the next task, which is the style binding, then now the input is actually the output of the previous task. So this whole section coincides with the one that is output from the previous task, right? It's a little bit complicated, but once you have this graph in mind, is I think kind of relatively easy. No? So you can already guess that the output of this TV task or this type binding task is going to be the input of the next 2 tasks. And this is indeed what happens. Now, if I now unfold the DMFT task, you're going to see that actually is repeated there. And in this case, again, the output of these 2 last tasks will coincide with the output of the workflow itself. Now, this so if you want the pressure 2, you essentially have to do the same, but just changing P1 by P2 and pressure 1 by pressure 2 in the files and the root path to the file. Sorry. So now you can actually go to the NOMAD, include these 2 files now there. And if I did it correctly before, then it should be recognized as workflow, and then it should be linking between these entries. And I think this is when hopefully you will see the value of these workflows right now, because we were able to kind of specify a very complicated workflow with like just a few lines in this YAML file. And interestingly, now you can zoom in. Now you will see the single point of that specific, let's say DFT in this case, but you can go to the DMFT. Again, you can click in the names, and then you will go to the specific sections or to the specific entries. So if you click in the name of the DMFT at pressure 1, temperature 1, we will see the entry of that specific calculation now. And lastly, I have 7 minutes left, so that's good. Because lastly, the last task of this exercise was to define a top-level workflow that groups everything together. And again, this is when things get even further interesting, because now you don't have to specify paths to the specific main files in your upload, but now you can actually point to the YAML file the YAML files that you already created. Because now the task will be the full pressure one. So this gray box in the documentation that we shared. Sorry. So this gray box now will be your task, and then the other gray box with the other. So now there are only 2 tasks in this top level one. And then once in this new entry that is going to be generated, once you click in pressure 1, so imagine that this is without any content inside, but once you click, you will be able to zoom in and then to see the task inside. And well, I'm not going to go into details. Again, inputs and outputs have to coincide between the first and the last workflow task. Sorry, so in this case, it's parallel, so it has to be repeated. So if you make the numbers, there should be like well, in this case, it's 2 inputs. I think the graph is not updated, but there should be like 4 outputs coming from these 2 tasks. Okay. Let's just include it into the upload page, and let's see what happens. The full workflow archive. Okay, that's the name of this thing. And now, if you see this, extra entry that we generated, now again, it should have like 2 tasks. Okay, one at a pressure 1, and just gonna move it around. The other one at a different pressure. This has like different outputs, one at temperature 1 and one at temperature 2. The same for the other pressure. And then the key is that if you now, what I said, no, if you now click in this task reference that we define, now you will see the zoom, and then we will cover the kind of workflow that we defined before. And then you can essentially nest as many workflows as you want. Try to define like the most organized way for your data. And that's it. If you click again the name, you will go to the workflow entry where again you will see the same plot as before. Okay, so lastly, I just want to say that of course this requires that you when you are treating your data and then you want to put it NOMAD, that requires that actually you have to work a little bit on how to prepare the data, and you have to do an extra step. Essentially, if something is standard enough, so if this kind of calculation is standard enough and the organization of data is standard enough, then it's easy for NOMAD to get this information from. So maybe you are not an expert on DMFT and DFT calculations, but this kind of workflow picture is very typical in this community, right? So it's very easy to have like a DFT calculation, then you do something like a projection on top of it, and then you do different DMFT calculations at different temperatures, a different number of carriers in your system, or different interaction of the electrons inside the material. So if this is standard enough, actually NOMAD could get this information together with us. So we have to develop this kind of picture. So there are different workflows that are recognized by NOMAD. So the single point is the easiest example, but there's also like stuff like geometry optimization. Now, before I show you like how the output calculation is just entering the next input in the next step, but this can be also like a geometry optimization, which you have one system input, then in a geometry optimization step, then the system changes, and then it's the input for the next. No? So in this case, it can be also recognized as phonons, molecular dynamics. So there's a whole tutorial a few months ago by Joseph in which he explained this. And the other one that is recognized is GW. That is the example that we uploaded in the blog first. No, in this case, it was DFT single point, GW single point, and NOMAD was able to recognize that extra GW workflow calculation. At that point, I didn't show you, and now, okay, I'm running out of time, but I just want to show you that case that we did. Let's go to the upload. Let's go to here, and then this was the example. No, so there's the single point, the DFT single point. So this only contains information about this task, but then the workflow, which was the one that puts everything together, contains information about all both tasks. Let's say. This is very cool because then you can do these plots already in NOMAD. So before I show you how you can query the data and do the plots in a notebook, but this is already implemented in NOMAD. You can get information about the backup. So actually the querying of this kind of data becomes much more easy because you don't have to extract that information yourself. It's already there now. And as you can see, for some reason this is not connected, but it should be connected because as you can see, we already recovered these tasks that are linked. And again, we can zoom in, we can go to the entries of that page. No? And this is an example of an automatic workflow. And in the last minute, I just want to tell you that actually there are certain constraints when you want to develop something that is being automatically recognized by NOMAD. Just give you like a few, well, we just give you like a few guidelines on this. So mainly, you don't need to repeat files inside subfolders. So there was no moment here where I repeated actually any files inside like the temperature 1 and the temperature 2. So it's kind of typical that people repeat like these files inside and inside. So if we have like a DFT calculation here, we don't need to repeat it like inside of the temperature 1 that belongs to a further step in the workflow. No? The other one is that, and this is maybe more critical, is that whenever you are organizing your data in NOMAD, if you want to be able to be recognized automatically, try to avoid that if you want to link, so imagine that you have two tasks and then a third task that you want to link in a serial way, no? So the moment that you put files in different subfolders, so if the middle task file is in a subfolder and then the other is in another subfolder, that means that in order for the processing to work, it has to go up and down. And this kind of up and down, so this kind of stairs going through the stairs in an automatic to be able to automatically recognize this is kind of impossible with the current infrastructure. So I will always recommend to keep like a linear upwards, downward, or top bottom structure. No, DFT. If you imagine this workflow I showed you before, DFT should be in the upper folder. Then you can create another subfolder with the type-binding calculation, and inside the type-binding create another subfolder. So the way that the last task is always reading outwards the files. No, I mean it can be also the other way around, read outwards, but that's kind of less natural when you are dealing with these kind of calculations. And whenever you want this, I mean the best is just contact us as developer. You can also develop yourself, but you can always contact us, and then we can work together to make your workflows recognized by NOMAD, so you don't even need to worry about writing these YAML files. And yeah, that's all for me. I hope this was not very complicated. I skipped well, we are preparing documentation for this to be more like rules, but I hope it didn't get. I hope it got exciting and not too complicated to understand all this part. And yeah, that I finish. Yeah, feel free to give any questions.
I guess you touched on this, but so essentially, do we have to put everything into a single YAML file, or can we use multiple? How should they combine?
So I think the best way is to put multiple, because naturally this is what happens also with any calculation, no? So here it will be very complicated to try to define something like in a singular file. So it's much easier, as I show you, it's much easier to define first for a pressure, then for another pressure, and then try to combine this in another different file that only points to this pressure 1 and pressure 2. Yeah.
And so for actually linking, you need to know the main file that you kind of point into, but then also kind of like further the structure down. So how familiar should people be with the NOMAD structure to use this YAML setup, and when would you recommend them using it?
So they have to be very familiar with. They have to get some experience on how the run section works. Especially that the fact, I mean, the only thing that you need to know is that there is something run system, run calculation, and run method. And this is a way that you will actually reference this kind of sections. You could, in principle, you could, in the very easy example I showed before, the single point, you could actually include like, okay, I want to include my methodology as reference, no? So you can actually include a new input method, and then the only thing that you need to know is that there's something called run.method. And that this is you have to include, but you should get like some experience, like having this, at least having this mentality there.
Okay, I see. You had some example as well at one point, right? For just to give people kind of a flavor with the spectroscopy.
Yes, so I'm gonna show exactly. I wanted to say that because I'm gonna show like a real life example, if everybody wants to see it. So I have to move it around because I'm going to open again the reprocess branch that Nathan was showing before. I think I just have to click F1. 11, sorry, F1. No, I can see. Wait, where is it? Just open the process, yeah, because I want to show like how a real example of some researchers that they went to they went on defining their own workflow YAML schemas because it is not implemented, and it is kind of complicated to implement this schema, as I'm going to show you here. So now I'm in this process version of NOMAD. No, I have a data set of some spectra data. It is published already available, and it's called titanium oxide simulated channels. So channels is X-ray absorption near edge spectra. And in this case, this data, which is kind of a big data set, let's say, well, I'm going to show you the folder structure so you see it. So there is these people, these researchers, did some calculations in different materials. No, so this label here means different kind of materials. And for each of them, they did different. They use different codes. They use something called exciting. That is the same example as we were showing during today's. But they also show a code ocean and etc. So they show different results. And for each of these codes, they use different K-grids, no? So same as Nathan was showing before about the kind line density, they use these different K-grids. And the thing is that they wanted to link for this code spectra, they wanted to put all the K-grids in the same, together with the DFT calculation, they wanted to put it in the same entry, no? And this is what you can find here in X spectra YAML. So if you click here, you will see that well, it was even more involved because for each of the K-grids, they have to put in some data together. But the thing is that if you click on this, so if you go into this file, you will actually see like all the tasks and how the inputs and outputs were very well connected. For them, I think that the point for these people was the most complicated point was to understand how to do it, because at the time we were just developing. Wait, cannot reach this one.
I think a really nice part here is also that because they put a little bit of time and effort into that, now for everybody who comes back to this set of calculations, they see how it was originally intended and how it was grouped together. So it's not just these loose line pictures. We can try and automate it as much as possible, but there will always be workflows. Again, we allow everybody to work the way that they like to work, right? And just extract it and standardize it. So by times you really have to write this personalized one. I can also imagine that this is very nice if you prepare a document or a paper for reviewers, because now a reviewer can basically go through the consistency and run through the exact set of calculations that you did and see what is going on and how you designed your workflow, your experiment.
Yeah, exactly. Nathan is totally right. So here you see it's a bit more involved, but once more, this is like some kind of, first somebody did some DFT calculation and then they did something on top of it. As you can see, there is something called core hole, well, it's a core hole spectra. So you can see that it is there. Not all the tasks are shown because, I mean, for optimization purposes, then you cannot show everything in this plot. But yeah, you see that it's already linked. So whenever you want to see like what's happening for, let's say, the grid 111, then you can go there and then you can link into, well, there are different polarizations of the incoming X-ray now. So there are different entries and then you can see what is being extracted from there. And interestingly, in this kind of example, we have both examples. So the case that where the people had, so the users had to define their own workflow YAML custom schema, but also the case where it was possible to automatically recognize this, and it was thanks to the people in this project that they prepared this very nice folder structure that you can see here. So in the case of exciting, it was possible to actually extract this information, and this I can actually very quickly show what is it, because I have already some experience. What is it? But in this case, this is the full workflow that the users, so the people uploading this, they didn't have to do anything. Just simply contact us, and then we implemented this for them. Although they help us in the process, no? And in this case, very nice. You can even actually see same kind of workflow. Still, there's some bugs, but still the kind of workflow similar to the other one. In this case, it's a little bit different because in this case, it's a Bethe-Salpeter calculation. And again, you can zoom in, you can go to the specific entry of one of these Bethe-Salpeter calculations. And again, you will have different photon polarizations. And then you can see what is happening for one of the photon polarizations, spectra related stuff. No? And yeah, that's my part. I hope this was, again, not too much, but just want to recommend, like, yeah, prepare a little bit. If you prepare a little bit the data, you at the end you don't even need to worry about having to write something, let's say for NOMAD or for any other